Actually, my background is from transportation engineering. Today, actually, my thesis is now in just studies the data collection. That's why today I would like to present about the overall about the AI in traffic road safety. So let's begin about the traffic accidents that impacts around all over the world. And according to the WHO, 1.19 million people and actually 50 million people are injured due to traffic accidents. In that, 90% of the road accidents occur in the lower and middle income countries, especially in the Southeast Asian regions. And most of the fatalities are among the vulnerable road users like pedestrians, cyclists, and motorcyclists. So what are the factors that affect the road traffic accidents? The significant factors is the speeding and driving. Drink driving also another concern that affects the road accidents. And then use of the helmet and seatbelts, and then there are no laws about the child restraint systems. And distributed driving, it's when you're driving, you're using the mobile phone calls, answering mobile phone calls, and then texting the message, or using another wearable device like a Bluetooth, listening to music. And another additional factors are poor road conditions and poor vehicle conditions, and the lack of the traffic enforcement and late post-crash response. So according to the global plan, it has 5 approach. First one is model transport and land use planning, and safe road infrastructure, and safe road use, and safe vehicles, and post-crash response. So let's check about the traffic accidents in Thailand. And according to the Ministry of Public Health, the road fatalities in Thailand is fluctuating, and the highest in 2011 and gradually decreased until 2021, but not in exact 2017 and 18. But however, in 2022 it increased a little bit, and in 2024, 2023, and 2024. More men are killed than female, and more than 75%. And most of the accidents are motorcycle accidents. And according to the age group, 36 to 60 years old are dead. It's the highest. And in Thailand, they have the pedestrian protection vehicle center, but there are no vehicle anti-locking, motorcycle anti-locking systems. Because in Thailand there are a lot of motorcycles, and this in the future we have to analyze about motorcycle, and we have to propose the motorcycle anti-locking braking system. In Thailand, they have the drink driving in laws and helmets, using helmets and seatbelt laws, but there are no child restraint systems. In Thailand, the death rate is 72.7 or 100,000 people for all road users. So what is the AI roles in the traffic safety? So AI can identify the risk factors, and we can predict the accident by using machine learning, and can develop the safety measures and monitor the real time the traffic scenarios. And what are the techniques in the traffic safety analysis? So for the classification and for accident prediction, it's predict about the categorical data like traffic accident, severity level, like minor injury, serious injury, fatality, or accident types, rent collection, and sidewide commission of pedestrian related accidents. And for the regression is we have to will predict the continuous data like estimating the traffic counts, traffic counts, and traffic accident counts, and estimating the traffic accident costs. So in the data accident data analysis, we have to collect the some data for, and the first one, and this includes the accident records, driver behavior, road characteristics, vehicle characteristics, and traffic volume and weather condition and other parameters. So after once we collect the data, we have to clean the unnecessary and missing values, and we have to remove the outliers. Also, and after that, we should do the data balancing because of most of the traffic accident data are imbalancing. For example, the fatal accidents are lower and the injury accidents are higher. That's why we have to make balance by doing undersampling or oversampling methods. So how AI can reduce the road accident? What are the applications of AI in traffic safety? So we can predict, as I mentioned above, we can predict accident prediction analysis, and we can, by using the ITS systems and driver assistance systems and drive behavior monitoring alert system and we can do everything in communication and driver education and training and using autonomous vehicles, road condition monitoring, images response optimization, and law traffic enforcement. So the first one is it's accident prediction with machine learning. And first one, we will collect the data and we use the proper machine learning algorithms to analyze the accident prediction frequency or severity level. And after that, we have to give feedbacks to the road users about and provide the alerts to the road users. And when we're predicting the data by using machine learning, it's difficult to interpret. That's why we can use the explainable AI to understand clearly. This one is the reference of accident prediction and the flow of some reference. And in the intelligent traffic management system, it uses the real-time data from the resources like GPS, cameras, and sensors. We can detect the road safety and to improve the road traffic flow. In the driver system and the lane system, it can assist the real-time corrections of windings that, for example, lane keeping assistance and automatic braking systems. And AI can detect the driver factor like drunkenness or inattention. And AI can detect the vehicles or obstacles in the driver blind spots. And this one is the driver behavior monitoring and alert system. As I mentioned above, AI can detect the driver behavior, driver features like eye blinking or yawning. It can alert to the driver. It can also alert to the drivers from sudden lane changes also. So what is the vehicle to everything? It has 4 parts. Vehicle to vehicle is exchange the information from one vehicle to each vehicle, like speed, location, and directions that can alert drivers from the potential hazards, like braking hard or vehicle approaching from at the intersections. And another one is the next one is vehicle to infrastructure. This is the communicate and to vehicle and the infrastructure like the traffic signals, traffic light, and street lights that alerts the upcoming red lights or road hazardous conditions. So the next one is vehicle to pedestrians. So this one is they communicate the pedestrians and vehicle that the carrying using the smartphones or other wearable device, and it can alert the drivers from the collision, especially in the private area or at intersections or crosswalks. And the last one is the vehicle to network. This one is it's connecting the vehicle to the network to get the real-time traffic data. And AI can use it in the driver education training by visual scenarios to get the safe driving habits. And that's meant in Chiang University, there was a joint program with Honor Thailand and Chiang University for students, free program for road safety. Another one is autonomous vehicles. As I mentioned above, is autonomous vehicles can and it have the sensor like again cameras and radars and that can scan the surroundings of the road conditions, and it can help automatic braking. And many other modern cars use the AI for automatic braking and the warning systems. Another one is monitoring the road condition. AI can detect the road conditions like it have the potholes or debris on the road, and it can alert the driver to alter the driver behavior. And the next one is in the emergency response optimization. If the accident happens to occur and from the real time and it connect with the network and it can give the exact location of the accident. For the traffic law enforcement, we can install the CCTV camera for detecting the speeding and illegal turns and some red light violations and speed detection. And we can also detect the seatbelt or phone usage. So as a case studies, there's the video-based surrogate measures for rural road in Thailand. And the first one will install the CCTV camera to detect the vehicles. And after that, we collect the vehicle once the vehicle detect, we do the vehicle tracking and we'll collect the data for the vehicle type, vehicle traffic volume, and speed detection. This is the video of vehicle position and movement. So what are the steps in the surrogate safety analysis? It's the first one, we have to identify the site, and once the site was identified, we have to select the surrogate measures, and we'll collect the data and data analysis, and we have to develop the risk assessment, and then we'll evaluate the safety analysis. Here the scatter plot shows the conflict level of the conflict level. The red color shows the high conflict rate, and the green color shows the lower conflict rate, the interactions. So this is the first side at the intersection. This intersection has two lanes and signalized intersection. This area is a high-risky areas, and we install the intersection collection warning system as flashlight system to alert the drivers from the intersections. So let's check the before and after treatment. So in the before treatment, we can see the higher risk conflicts, and after the treatment, there are they decrease the higher conflicts significantly. So another side is in the cuff segment is this segment is in the cuff section is it has the high traffic volume with the high speeds, and we install the optical speed bar and it warns to the drivers to reduce their speeds approaching to the cuff. And for in the before treatment, it have the higher risk conflicts, but after the treatment, it decreased significantly high risk conflicts. Thank you.